Hey friends, welcome back. In this video, we're going to be talking about a really important idea, economic growth. This is probably the most important idea in all of macroeconomics because it is what's responsible for the increasing standard of living in the United States that has really taken hold over the last 150 years or so. It's also the only realistic hope for poor countries to be lifted out of poverty. About half the world lives off $2.50 a day or less, and about 80% of the world lives off $10 a day. That's about $3,650 per year. Not very much. Economic growth is essentially the only hope for these vast swaths of human beings to improve their life to something that looks like the United States. Here in the United States, relative to around the year 1900, the typical American can now consume 8 times as much stuff. We make 8 times as much money after adjusting for price changes, and we're able to consume about 8 times as much. And it's not just that we have more stuff, we also have better stuff, like indoor plumbing. Do you know how great indoor plumbing is? Well, we all take it for granted now, but it's a big deal. Antibiotics. Many people I know have had their lives saved multiple times by antibiotics. How about music in our homes, right? I mean, in the year 1900, the only people that had music in their homes were essentially European royalty that had orchestras on standby. Today, I have more music on my phone than I'll ever listen to. Right? So it's not just that we consume more stuff, we consume better stuff. And all of this is because of economic growth. Now, we define economic growth in prior sections, and that's basically the ability to produce increasing quantities of goods and services, and that's important because that affects how much we're able to consume. Now, there have been some interesting estimates done about economic growth over the very, very long term by economist Brad DeLong. This guy estimates that in the year 1 million BC, our ancestors had a GDP per person of about $150. So they were out there, collecting berries and, making some rudimentary tools and that kind of thing, maybe even doing some cave paintings or something. And they were making about $150 a year. And in the year 1300, about the same. Right? So for all this period of time, this is, for 1 million and 1,300 years, there was no economic growth. The typical person on this planet didn't see any improvement in their standard of living. They're making about $150 a year. And, their life expectancy was in the 30s, typically. Okay. So over that period of time, no economic growth. We didn't really start seeing significant economic growth until the Industrial Revolution, which started around 1750 in England. So here's a definition for the Industrial Revolution: the application of mechanical power to the production of goods and services. So reflect on this for a minute. Prior to the Industrial Revolution, essentially all production of goods and services was related to what we could get humans or animals or a team of humans and animals to do. What happened, what kicked off the Industrial Revolution, is someone basically put a water wheel on a river and used the power of the river to help with the production of textiles. Textiles is cloth, basically. So it may sound like kind of an obvious thing or a trivial thing. Oh, put a water wheel on the river. But this was a seminal moment in human history because this was when the production of goods and services was no longer tied to what we could get humans or animals to do. We used some new form of power in the production process. So that was a big moment. And it happened around 1750 in England, and it was a slow process to get going. But anyway, that's where the Industrial Revolution started, and that was the kickoff of meaningful economic growth that we all benefit from to this day. Our standard of living today is just the accumulation of economic growth, basically since the Industrial Revolution. All right. So, why in England in around 1750? Well, that's a good question. If you look at England on a map, it's in the middle of the North Atlantic. I've been there. It's cold. It's crappy. Well, I'm sure it has nice times or whatever. But anyway, why England, right? Well, economist Douglas North says that, well, it comes back to the glorious revolution of 1688. What happened was a group that wanted a strong parliament came into power and basically booted the king out of control of the government. This is a big deal because now the government was not under the control of the king and could make kind of credible promises about protecting property rights and protecting wealth and preventing tax increases. And another really big important thing was that now the court system was also independent of the king, and so the court system could really do a good job at credibly enforcing the laws for the first time. All of this creates an environment where it's safe for entrepreneurs to take a risk. If you know that the riches you will get from creating a new approach to producing a good or service or even inventing some new products will be yours, then you might have an incentive to put your wonderful idea actually into practice and create some value for other people in society. And ultimately, that's how we all get paid. That's what creates wealth. You can only really get wealthy if you create value for other people. And this glorious revolution is believed to have set the stage for this by essentially getting the king out of power and creating a government that could actually really work for the people and protect their rights. This created an environment where economic growth could happen. Now here's a look at economic growth over the long run, right? Here is from 1 million to 1300 BC, nothing, basically nothing. Right? These people who lived in 1300 were literally no better off than the people a million years before. That's a stunning, stunning run of zero progress. And then 1300 to 1800, we get a little bit of something. But then you start to see the economy really start to grow worldwide from, 1800 on. So you might look at these growth rates, 1.3 to 2.3%. Well, that's not that big of a difference, right? Going from 1.3 to 2.3. But one of the things you'll see is that small changes in growth rates really matter. It does make a big difference to go from 1.3 to 2.3. Over a 50-year period, you can see that 1.3% gives us a 91% total increase, and 2.3% gives us a 212% total increase. So you might look at this and be like, oh, 1.3 to 2.3, not a big deal. It is a big deal. Now, we have seen in the current century what looks like a decline, and there are some possible reasons for that, but, a century is a long time, so we'll see how the rest of this one plays out before we, start predicting our doom or anything like that. So here's another look at growth rates mattering. Look at Nigeria, Namibia, and Turkey. In 1960, they were pretty close to each other. Some differences in income, but pretty close to each other. Here are their growth rates over that period. 0.5%, 1.8, 2.7. You might look at this and go, well, not a huge difference there, but it is a huge difference. Look at how it all plays out. This is over a 55-year period from 1960 to 2015. Look at how much the GDP has increased. Nigeria and Turkey originally pretty close to each other, but after this, 55 years, you've got Turkey with an average income of about 4 times what Nigeria has. So small changes really, really do matter, even over just a period of 50 or so years. Okay. Now, ultimately, this stuff matters. The incomes here matter because this affects standard of living, right? And it's not just that people can buy more stuff. It also affects the quality of life and life expectancy in other ways. And in rich countries, we only have about 4 out of 1,000 babies die. That's infant mortality. In poor countries, it's like 10% of small children are dying. So children dying is a bad thing. This speaks to the power of economic growth, right? So it's not just more stuff. It's first of all, it's better stuff, and it's also things like health outcomes, which are really important. Um, and you'll see over the course of your life that societies where economic growth isn't happening, they get frustrated and big changes happen. In my life, the Soviet Union fell apart basically because the standard of living was not increasing quickly enough in that country. We've seen Argentina in recent years fall behind. They used to be a relatively rich country, but they have lagged behind and had a series of economic crises that have really caused them problems. In general, economists talk about high income countries and developing countries. The high income countries are the United States, Western Europe, Canada, Japan. There are certain places where economic growth has really happened and continued to happen, and those people live good lives today because of it. The rest of the world are developing countries. Now there is kind of a third class called newly industrializing countries, and those are countries like Singapore, South Korea. So these are countries that have kind of emerged from the morass of developing countries and are attempting to join the high-income countries, and we certainly hope they do. Right? So there are big differences in real GDP per capita, which is the same as income per person across the world. Qatar in 2016 had about 130 grand per person. That's pretty good. The United States is around 60, FYI, 60 grand per person. Somalia down at 400. Okay, that's a really, really, really low quality of life. Be thankful that you don't live there. Here is a visual map of incomes around the world. GDP per capita, same as income per person. And you want to be in the green countries, friends. Green countries are the greater than 20,000. And I'm frankly a little bit surprised to see Russia up here. They barely made that group. But the United States very comfortably in that group, and even more comfortably some of these Middle Eastern countries like Saudi Arabia, Qatar, things like that. All right, so it's just to give you an idea. The poorest parts of the world here in sub-Saharan Africa. The Sahara Desert is up here, so this is sub-Saharan Africa down here. Really, really low growth rates, and over time there are a lot of places like thinking about Somalia. I mean, a million years ago, the typical person was living off $150. Today, Somalia only living off $400. So things have gotten better, but really not a whole lot better than things were a million years ago in Somalia. So almost no economic growth has ever happened there, right? So it's pretty crazy when you think about it. Now, income is not the only thing that matters. Health outcomes are really important, and even in these poor countries that I just kind of bash, these poor countries in sub-Saharan Africa, they have made some really significant progress in other areas not related to income, like health and education and civil rights and that kind of thing. So it's not all about income. Other factors lead to a good life, but income is really important. You need to be able to buy medicine and food, and a house would be good too, right? Healthcare, all very good stuff. So anyway, now that we have some idea about what leads to increases in standard of living over time, or at least that there are differences, now we can build a model of what actually causes these differences. Right? Why is it that economic growth occurs in some areas and not others? Well, we're going to develop an economic growth model to try to help with that. Now, we saw in the last chapter that labor productivity is the key to long-run economic growth, and that the keys to labor productivity are capital per hour worked. So this is like machines that help workers be more productive, or you could think about human capital too, like education that helps workers be more productive. So we need capital, machines, and education, and we need improvements in technology. Now we're going to build an economic growth model that allows us to explain the relationships between capital and technology and output, which is what real GDP is, and that's where all income comes from. All right. Now, before we do that, I want to come back a little bit here and do a little bit of math so we can think about how to find figures like what we have here, right? I mean, how is it that, you know, growing at 0.5% per year allows you to calculate you'd go from 3970 to 5266? Well, you may recall from the last section that we have a formula for growth rates, right? I gave you this this formula some time ago, but basically a growth rate is equal to, so let me see, growth rate is equal to the change divided by the starting value, whatever that is. And then to make it into a growth rate, we multiply by 100. Now to find this change part up here, a lot of times you want to do the new value minus the starting value to find out what the change actually was. And it could be negative. You could have negative growth. It's possible. Now, over long periods of time, if you know what a growth rate is, like say you know that the growth rate is 0.5% in Nigeria's case here, or 1.8% in Namibia's case here, and you know that this is taking place over a 55-year period, right? We know there's a better formula to use, right? The growth rate over a long period of time, if you have the annual rate, is something like, oops, let me get my pen going here, is something like 1 plus g raised to the t power, where g is the annual growth rate in decimal form, right? Whenever you do math with percents, you need to convert it into decimal form. And t is the number of years that has gone by. Okay, so let's look at Nigeria's case here. We know that Nigeria has had a 5%, or sorry, a 0.5% growth rate over this 55-year period. So in decimal form, you got to move this decimal over 2 places. And so it's something like 0.005. And for Namibia here, you would need 0.018 as G and 0.027 for Turkey. Just doing that conversion to be able to plug into a formula like this. So remember that Nigeria started with 3970, right? And they grew at 0.5% for 55 years. So if you take 3970 and you multiply it by this thing, right? 1 plus g, g for Nigeria is 0.005. You raise that to the power t, which is the number of years, so that was 55 years, you're going to get 5266. At least I hope so. So let me break out my calculator here. Let me clear this out here. So we've got, in the parentheses there, we've got 1 plus 0.005. We want to raise this to the 55th power. We'll get that thing. We multiply this by the 3970, and we get 5223, friends. And that's pretty close to what we have here, 5266. It's just a little rounding error. That's accounting for the difference, so no big deal. This is how you make these this is how you do these calculations. So you could apply an analogous example of this in a lot of cases to get the effect of a small growth rate over time. Now comparing that to Namibia's case, they started with 4071, and if you multiply that by 1 plus 0.018 raised to the 55th power, you're going to get roughly 11191, as our authors have gotten there. All right, so that's how you could do some of those same calculations that were done here in the background. I just wanted to show you the math for that because I put a question doing that math, exactly what I just did, in the homework in the test. So heads up on that, right? Okay, so we know, coming back to our growth model here, we know that we're trying to explain long-run economic growth, and that labor productivity is what explains it, and that labor productivity is affected by capital and the level of technology. Okay, we know that the more capital someone has, or an economy has, the more they will be able to produce. Okay, so we know that if we were to actually try to graph something like this, right, and we wanted like real GDP, this is output, and we had capital down here, we know that there's a positive relationship here, that more capital results in more GDP. However, it turns out that the relationship looks something like this. It's a curve where the slope diminishes. Notice that the slope of this thing up here with high levels of capital, that the slope is relatively flat, right? And with low levels of capital down here, the slope is steep. The slope tells us the rate of change, right? So this tells us that if you have low levels of capital, but you add more, you're going to be able to get a higher rate of change here. That's a steep slope. Than out here, when you have high capital already and you try to increase your capital even more, you have a flatter slope showing you get less real GDP increase for the same increase in capital. You might wonder, why is that? Why would I get less or a lower increase in real GDP just because I already have a lot of capital? Well, capital has what's called diminishing returns, all right? Think about this. Imagine that, this is a horrifying example, okay? I'll tell you that in advance. Imagine that you own a sweatshop, all right? And you've got all these kids that are, sorry, I told you it's horrifying. All right, whatever, we don't need kids. You got people in the sweatshop that are making clothes for you, and they're doing it all by hand. If you add your first unit of capital, so remember, capital is a manufactured good that helps in the production process, so like a sewing machine in this case. So say you have like 10 workers stitching clothes together and you add your first sewing machine. Those workers are going to keep that sewing machine running 24 hours a day, and you're going to keep, you're going to get a maximum high rate of return out of that sewing machine, that first machine. You might think, oh, that's great, I'm going to add a second machine. So you add a second machine to the same 10 workers, that one will also be pretty productive. But imagine what happens, how much more productive can you be if you just keep adding more and more machines to the same pool of workers, right? Eventually you get to a point where each worker has their own sewing machine. Now it's not possible to keep the sewing machine running 24 hours a day. And so the return of the last sewing machine is not as high as the return to you as an investor of the first sewing machine. That's what's happening here on this graph. When we're talking about just your first few sewing machines, that's your low levels of capital down here. Oops, I erased my graph here. Right? You have low levels of capital down here. Notice, say you go from like 1 to 2 units of capital. Well, the increase in real GDP can be measured over here on the vertical axis in GDP. Going from 1 to 2 units of capital gives us an increase in GDP equal to this area. I'll call that distance A. That looks pretty good. Now compare that to adding a unit of capital, when you are over here, like having, maybe going from like 11 to 12 units of capital. Well, this relationship that we've plotted out here says, well, you're still going to get some increase. It's just going to be pretty small, right? I'll call that B, all right? The fact that you get less output out of your last few units of capital as compared to your first few units of capital is an unfortunate truth, and it's called the law of diminishing returns. So that happens with adding capital. So we know that adding more capital means you're going to get more output. It's just that capital suffers from diminishing returns, and that's exactly what's going on with this slope falling off here. Here you have a high slope showing that you're getting a high rate of return to adding more capital. Here you have a flatter slope showing that you're going to still keep getting some rate of return, but it's going to be less. That, friends, is the law of diminishing returns. Now, in addition, recall that although capital is really important, so is technology. And recall the definition of technology, right? Technological change, as we've written it here, is that you're able to get more output with the same quantity of inputs. Okay, well, capital is an input, right? These are machines that are used to produce output. So if we have technological change, it means that for every level of capital we have, we're now able to produce more. And so imagine we were originally sitting here with like 2 units of capital, okay? And we were, so we were right here on our function here. By the way, this is called a production function. It just specifies the quantity of input, capital, with the amount of output that can be produced. So that's a production function. So imagine we're here at this point on the production function where we've got 2 units of capital. Technological growth says, well, with that same amount of capital, now you can get more output. So instead of this level of output here with 2 units of capital, with technological change with the same 2 units of capital, now you can get more output. So maybe a point like up here, right? But this is true for all levels of capital. If you were originally sitting here on the production function with 12 units of capital and you were getting some amount of GDP, with technological growth, that same amount of capital, now you can get more output. So spotlight up here on the GDP axis. So what we've got here is that with technological growth, there's a whole new relationship between the amount of capital and the amount of GDP. So we need a whole new production function to capture that. All right, so I'll call it production function 2, and here's production function 1. So when what we're developing right here, this is the economic growth model, and I have a better picture of it for you here in a minute. But basically, when we add more capital, we model that as a shift along a production function. Right, going from 2 units of capital to 12 units of capital, we'd be going from point A here to point B, for example. But if we're getting more technology, we shift up onto the new production function. Right, new technology might take us from a point like A to C or from B to D up here. All right, that's more output with the same amount of capital. So technological growth or technological change is modeled by a shift up of the production function. More capital is modeled by movement along the production function, like from A to B. Now going from A to D requires both. You need more capital and better technology. All right. So anyway, that's a rough intro to the growth model that we'll work with here. Now, that issue of the diminishing returns to capital is really important because what it suggests is that if you're a country with high capital stock, like the United States, you're not going to get a whole lot of growth out of just adding more capital and accumulating more machines. We really do need technological growth to sustain long-run economic growth and to increase our standard of living even further than where it is today. So technological change is actually the real secret sauce for long-run economic growth. So where does technological change come from? Well, better machines. Recall that more machines, that's an increase in capital. That's a movement along a given production function, right? But here we're talking about better machines. So you might have the same quantity of machines, but they're actually better, right? Compare a steam engine of yesteryear to, the amazing diesel engines or even nuclear engines that we have today, right? The new engines are able to, get a lot more productivity out of the fact that there's only one engine, right? So you could have a steam engine in the year 1900 or a diesel engine today. You still have 1 unit of capital. It's just that our machines are way better. Our current engines are way better. Now, in addition to the more machines, we've got increases in human capital. So this is just an increase in, this is just more capital, a movement along a given production function, but it's also that we have better human capital now. The skills that workers get are more aptly suited to what they need today than was in the past. The information and the knowledge that workers get is just better than the education that people got years ago. Now, in addition to all that, we have much better means of organizing the factors of production. Probably the biggest advance in organizing production occurred with the assembly line, right? Before the assembly line, cars were made by having a team of a few people do every task associated with constructing a car. Now, there are hundreds of things you have to do to build a car, right? Maybe thousands. And if you have just a few people doing those tasks, each worker is responsible for doing, a few hundred things. Now, the assembly line changed all that. Instead of having a few workers do all of the work on a car, the assembly line brought the cars to the workers, and each worker was now responsible for working on all of the cars, but only doing a couple things. This allowed those workers to become more specialized. They're able to do the jobs faster and at a higher level. And so what Ford did was he basically had the same number of workers, he just reorganized them and got way more productivity out of them. That is classic technological change. Finding a way to get more output with the inputs you have. That's exactly what Henry Ford did. All right. So technological change is really important. Now here's a much prettier picture of the production function. A couple differences between the drawing that I did and this one. Here you have everything is broken down per hour worked here instead of just how much capital and how much GDP. They broke it down per hour worked. Doesn't really matter. I'm just pointing that out. So you have here capital per hour worked, real GDP per hour worked, and you have a production function, right? You can see the diminishing slope, and you can see that on the capital axis, we're adding the same 25 units of capital going between these 4 points, right? 75 to 100, 100 to 125, 125 to 150. So 25 units of capital on each step here, but you can see that we're getting less and less output per unit of capital. Going from 75 to 100 got us 5 more units. 100 to 125, only 4 more units, and 125 to 150, only 3 more units. So you can see the diminishing returns to adding capital here. And of course, here you have the technological change. Notice we have the same amount of capital per hour worked, 150 bucks, but we're getting more output out of that same amount of capital. That's the definition of technological change. So we model technological change by a shift up of the production function. We need a whole new production function for a new level of technology, but improvements in capital, we just shift along a given production function to talk about that kind of growth. All right. So here is an interesting example that highlights some of the important aspects of this stuff. Back in the day, Soviet Union was a communist country. The government essentially owned all of the businesses and made all the production decisions. Now, the Soviets did really well in the 1950s with communism because after World War II, basically the Soviet Union didn't have much capital stock left. It had been pretty well bombed by the Germans. So they had very little, relatively little in the way of machines and factories and things to help them be more productive. Now, what happened in the 1950s is the Soviets focused on improving their capital stock. And at the beginning, the slope is steep, right? Adding a few units of capital here, you're going to get pretty high rate of return. And that's exactly what happened to the Soviets in the 50s. They were doing better than the United States, actually getting higher growth rates here because they were focused on adding capital. This led to, among other things, a crazy moment at the United Nations where Khrushchev, the leader of the Soviet Union, said, he banged his fist on the table and he said, translated, we will bury you. And he was talking about the Soviet Union going to bury the United States and bury the West because they felt their model was better. And it was better for a little while. When you're adding low levels of capital, when you're at low levels of capital and you're a communist country, you can just dictate that we're going to add more capital and you're going to see the growth associated with that, right? But what Khrushchev didn't know was that the law of diminishing returns was coming for them. And they can't just keep adding more and more capital and keep seeing those high growth rates. And, they didn't see the growth rates that they wanted. Soviet managers, these people that run the companies, their whole system of evaluation was based on, did your factory produce the amount that the government ordered? And if it did, you're doing fine. The managers really didn't have an incentive to think of new ways to combine the workers with the other factors of production to produce the output. The managers basically were graded only on did they produce the right quantity, not did they improve their ability to do so. And we know that people respond to incentives, and without incentives in place to create that innovation, the technological growth that the Soviet Union would have needed to sustain high rates of economic growth did not occur. And so ultimately, the United States caught up. We continued adding capital. We just weren't able to do it as fast as the Soviet Union because we didn't have a communist government telling us to do it, right? But we did have capitalism, which is a system that rewards creativity. And creativity is what creates technological change and, in the end, long-run economic growth. It really is all about creativity. Okay, now this economic growth model that we've developed here is basically the Solow model. It's called the Solow model because it was developed by this guy, Robert Solow, won the Nobel Prize for it back in the 50s. One of the sort of simplifications that Solow made was he didn't try to explain why technology improves. He just treated it as, what's called an exogenous variable. It just happens by chance if you're lucky. And he was assuming it was related to scientific discoveries, and there's some validity to that. But it's much more if economic growth is the most important thing ever, and it depends on technological change. Maybe we should try to explain where technological change comes from. And Paul Romer did a good job at that. Paul Romer developed new growth theory, which basically says that technological change is a consequence of the economic incentives that are in place in a society and how well the market system is working, right? He says basically that knowledge capital is critical. This is more important than physical capital. And ultimately, the reason knowledge capital is more important than physical capital is because physical capital is what's called a private good. We say that it's rival and excludable. And what that means is that when one person is using it, other people can't. That's what rival means. And that's the truth with most machines. Remember your horrifying sweatshop that you used to run? A sewing machine that you buy for your workers is not available for other companies to use. It's also excludable in that you can prevent other people from using the sewing machine that you bought. So that's the nature of physical capital. There's nothing wrong with that. But knowledge capital is much more powerful because it's non-rival and non-excludable. Meaning that, an idea can be used by multiple people at the same time, right? So if I come up with a new production process, other people can take that idea and maybe expand their businesses as well. So if I come up with a new idea like this, it benefits more than just me. It can benefit lots of other people at the same time. Unlike physical capital, where I buy a new sewing machine, it benefits me and my company, but it doesn't benefit all of society the way that a brilliant new idea will, right? Ideas are also non-excludable, right? You can't prevent someone from getting it if they don't pay for it. An idea can be described in words, like Henry Ford's assembly line. All right, well, that was a brilliant new idea. And, although Henry Ford was the creator of it, that idea was spread to many other businesses and dramatically improved our society's ability to produce goods and services. That's the nature of knowledge capital. It's a public good in that and that creates these increasing returns, right? If you come up with a new idea, there's way higher return to that idea than coming up with than just buying a new machine or something like that. So knowledge capital is extremely powerful, much more powerful than physical capital at growing the economy over the long run. Now, one of the problems with knowledge capital is that because it has these increasing returns, it benefits everyone in society. Private enterprises will underproduce. Private enterprises try to develop their own ideas, right? And they do so based on their private incentives. But because the private benefit of developing a new idea is so much less than the total benefit to society, essentially, we underinvest in knowledge capital. And this is why the government plays an important role in knowledge capital. I mean, think about what Bell Labs did. You may not be aware of Bell Labs, but they invented transistor technology, and that underlies essentially all computers and some other industries as well, actually. Well, Bell Labs, they developed the transistor technology. They didn't actually make very much money off of it at all. Immense profits were made by other firms that used their technology, right? And because Bell Labs, doesn't enjoy the full benefit of their idea, Bell Labs and companies like them don't produce enough new ideas. They produce enough based on their own private incentives, but because of this massive amount of increasing returns, these spillover effects, if you will, there's overall an underinvestment in new knowledge generation. And so the government can play a role in stepping in to facilitate this type of knowledge capital. What they can do is protect intellectual property rights. That's really important. But probably more important is subsidizing research and development and subsidizing education. By doing all of these things, we create an environment where more research will happen, more technologies will be developed, and ultimately we'll have more economic growth and a richer society because of it. All right. Now, we'll talk about some of these ideas more in depth. With regard to protecting intellectual property, essentially this is about allowing firms to profit from their own research and their own ideas. This is really important. And so the way the government does that is by protecting them with patents and copyrights. A patent is a legal designation that gives someone exclusive right to their invention for 20 years from the date that it is, invented or filed with the government. And so by giving someone exclusive use to their idea, they create an incentive for people to come up with that idea in the first place. Now, after 20 years, the protection of that new idea is removed and it can spread to everyone in society. So that's pretty good. This is ultimately why some prescription medications are so cheap. For the first 20 years, there's a patent on that new drug and they're really expensive. And then after the 20 years are up, well, now it belongs to everybody and companies can make generic versions and charge much lower prices for it. Copyrights are similar, except they're for creative works. Now, subsidizing research and development is important. The government does perform some research directly, and they subsidize other research by giving companies tax breaks if they're performing research and development, and also by funneling money to researchers at universities and similar institutions. So in addition to subsidizing R&D, research and development, the government subsidizes education. Here in the United States, just like in basically all other high-income countries. We do it, and we do that not just because of the improvements in technology that we think will result from this, but also as an equity issue to provide people with opportunities. We know that education is probably the best mechanism for upward social mobility that our society has, and so we subsidize education to give everyone a chance at getting the prize that is, richness here in the United States. Right? That's the idea. Okay, so we'll come back to some of these ideas here, but suffice it to say that uh, technological growth is the most important thing to sustain long-run economic growth, and long-run economic growth is what's going to improve our standard of living and also lift the masses of human society out of poverty. So, technology is important. So, we've learned a lot of interesting and important stuff about the economic growth model. And one of the most interesting things about it is its prediction for poor countries. Recall that the economic growth model, basically, we have something that looks like this, right? Sorry, maybe it flattens out a little bit more here. So you've got capital and you've got production, so real GDP over here, right? Recall that the slope of this production function tells you about the rate of return of capital. How much additional output will I get based on an increase in capital? So here's the deal. Poor countries have low levels of capital. Rich countries have high levels of capital. So what this suggests is that for poor countries, they can grow pretty fast if they add some capital because they're down here where they're still getting high returns. Rich countries have the diminishing returns kicking in already and so are getting lower rates of return for adding capital. This suggests that poor countries should be able to grow at a faster rate than rich countries and maybe catch us someday. Probably not, but they at least can get nearer to us, right? In addition to this issue with capital, they can also, these poor countries, benefit from just straight up installing our technologies that we create. Poor countries have crappy levels of technology, so they don't even have to bother creating their own. They can just get from the rich world what we create and plug it right in. Right? There are big parts of Africa that never had wired phone lines. They never had landlines. They went from nothing to cell phones immediately. This is a great example of that, right? Because they can just take what we developed, cell phone technology, and plug it right in. They leapfrog our technological states, and they don't even have to bother with landlines. So they can just plug our technologies in immediately. That helps them catch up to us also. So we would expect that poor countries can grow faster than rich countries and maybe someday catch us. In fact, it's called catch-up growth. Even though most people don't think these countries are actually gonna catch poor countries aren't actually gonna catch rich countries, but they can get close. The reason they won't catch us is because by the time they're approaching us getting rich, they're going to be suffering from the law of diminishing returns of capital, and they're already going to have the most up-to-date technology. So, anyway, what we have here on the graph, this is it's called the catch-up line, if you will. And basically, what you have here on the vertical axis, this is GDP growth rates. And down here you have the starting level of capital. All right, and what we see here, what this catch-up line says, is that with low initial levels of capital, so down here, right, with low initial levels of capital, you're going to have pretty high rates of economic growth, right? Because you're getting, you're on that steep part of the production function still. If you start with a high level of real GDP per capita, right? Here's a point on the line here. It would suggest you're going to get a lower growth rate, something like that. All right. So this catch-up line is kind of a predictor, right? It tells us based on the starting point, the initial level of capital, what we think the real GDP growth rate might be. Now here is a demonstration of what we're talking about here among high-income countries, right? These are countries that have high incomes now, in part because they have seen a lot of growth. And so it looks pretty good when you include these rich countries. There's the United States, you've got Korea and Singapore. They started out with very low levels of capital and have done really quite well since 1960. And so you see basically the relationship holds up that the catch-up line suggests, right? That with low levels of starting GDP, these countries had high rates of growth. Okay, that's great. And that all looks fine and good until you add in all of the poor countries that have seen no growth, right? Compare the graph you're looking at now to this one, right? All we've done here is add a bunch of countries that we have data for. This is the full set of countries that we have data for. This is just the set of rich countries that makes our catch-up growth hypothesis look good, right? When you add in all of the countries, basically it looks pretty worthless, doesn't it? Indeed, it does. So, what's happening here, right? Why isn't catch-up growth happening in most of these countries? It is happening in some of them. Look, these, the Taiwans, the Singapore, Korea up here, things are going really well. Even Portugal, Ireland, these places had low levels of output and originally, and have seen huge amounts of growth, right? So why does it happen in some places and not others, right? What is it about these countries in here, these poor countries, that have caused them to stay poor? Um, well, we have some theories about that, and they're important, right? Essentially, for one thing, recall where the Industrial Revolution started, right? It started in England because the king was booted out of power and the government could finally credibly enforce property rights and contracts and that kind of thing, and ultimately enforce the rule of law. So, of course, failure to enforce the rule of law is important. That's one of the main causes of poor countries staying poor. They don't enforce the rule of law. There are wars and revolutions. These reassign property rights, and basically a lot of times are just reset buttons on the whole society, the whole economy. War will really drag an economy down. Also, you can't be more productive if you have, poor health and you're not educated. In addition, we saw in the last chapter how important a healthy financial system is to long-run economic growth and to economic growth in general. And if you have low rates of saving, of course, there isn't money around to invest, right? Savings equals investment in the macroeconomy. And what do they invest in? Well, machines to help us be more productive for the most part. And so, if you have a society with low rates of saving and investment, then there aren't going to be excess funds around that can be used to, increase the capital stock and grow the economy. In a society where they have really low incomes, they spend a high percentage of their income on food. If you're in Somalia and you're making $400 a year, you can imagine it's pretty difficult to save, right? And so this problem kind of feeds on itself. These poor countries have low rates of saving because it's really hard to save if you make no money. And so they stay poor because of that. Now, a lot of times they can get loans from things like the World Bank, the International Monetary Fund, but in the end, it's a bad problem that seems intractable sometimes. So we'll take a look at these on these upcoming slides. Rule of law, basically the ability to protect property and enforce property rights. Property rights are critical because essentially, if entrepreneurs don't think that they'll be able to keep what is theirs, if there aren't good property rights, they would have no reason to think that they would keep the property that they earn. It's very difficult to risk starting a business in that environment if there are no property rights. So people don't, and places stay poor. So you've got to have a strong rule of law that enforces property rights and also contracts. You got to enforce contracts so people can be, expected to hold up their end of the deal. A lot of business is run via collaboration, and if you can't depend on your partners to follow through on their contracts, then it's hard to get the economy rolling. So you want an independent court system as well. Now here's an example of two countries, Mexico and China. China has basically become more of a capitalist country. They're still on paper a communist country, but they have a lot of market activity going on. They've made some significant reforms that are unleashing economic growth in China. Now, Mexico, on the other hand, they have a lot of problems. They have a corrupt government, they have a weak rule of law, and their court system isn't very dependable. And so basically, they do not have an environment where you would expect to see economic growth. Look at the growth rates here in real GDP per capita between these countries. In the 80s, Mexico straight up went backwards. And in the decades since then, in the time since then, they've done better, but still pretty low growth rates. And so, compared to China, China experiences these high growth rates. And so, you know, although Mexico still has a higher income per person, it's just a matter of time before China overtakes them. This is the effect of strong rule of law. China has a strong government. They enforce their laws. Mexico has all this corruption, and so they don't see the economic growth that China does as a result of that. All right. So we talked about wars and revolutions and public health and education and low rates of savings. These are all issues that relate to poor countries staying poor. Poor countries have more wars and revolutions than other places, and that really restrains the economy. They have they have crappy education and public health, and it's really hard to start a new business if you are sick or if you have a really low education level. Um, and also, we already talked about savings rates and investment. So maybe if these are the problems, if these are reasons why poor countries don't experience high rates of growth, it's not surprising then that some growth policies that are routinely suggested by economists surround fixing those things. Enhance property rights and the rule of law, for example. Improve health and education. Adopt policies that promote technological advancement and the adoption of technological improvements, right? So these are important. Promote policies that increase saving and investment. You can't grow an economy if you don't have excess funds around to invest in new machines and new technologies. If you create policies that promote savings and investment, then you are ultimately, promoting long-run economic growth and improvements in the standard of living in a society. You can do this, the governments can do this by, creating like tax benefits for savings, things like that, right? And the way this basically works is that if you give a tax benefit to saving, people will save more, right? That increases the supply in the market for loanable funds and creates an environment where there will be more money around to invest in new technologies and um, capital. So lots of ways to do it. Anyway, these are your growth policies. Um, Enhance property rights and the rule of law, improve health and education, adopt new technologies, and promote savings and investment. So, hope this stuff was helpful to you and you enjoyed this lecture. I will see you in the worksheet video, friends. Thanks for watching.
A Kearns production. All rights reserved.